Hi, we are Engineering Brothers, and once again we have come out with our another interesting problem or interesting analogies over here. In our previous part, we have considered what seems to be the position of our poles, and let us consider what is the exact stability statement for that one over here. I have already analyzed over there. In this case, I'm just going to cover up all those detailed analogies over here. In our left hand side, we can say that the single real root that has been present at this point over here, and we have considered that point into two parts over here. At first, we are having at s is equal to minus of our sigma, and the next one will be s is equal to sigma. For that one, what seems to be the time domain equation over there, I have already shown you how to go to that considered part, and this is the considered point for our location of our s-plane over here. And after that, or after we do follow up with our inverse Laplace consideration over there, how to get to that output response over here, that is the considered point, or that is the output response that we are having over here. Now let us just do start over here once again. First of all, the considered poles are placed at s is equal to minus our sigma. Now what is the equation over here? According to our transfer function analogy, we do know that Cs divided by Rs, and the equation will be A divided by our S plus sigma. And what we are referring according to our S-plane over here, according to our S-plane analogy, the exact pole location will be in this way, and the cross has been indicating that over here. So the S-plane will be considered at the left hand side of our S-plane over here, and quite naturally you can see that this is our transfer function equation over here. Now once again, if you just do apply the inverse consideration, but before I go into that inverse Laplace consideration, we should say that we should apply the impulse response over here. Now that actually implies that the Rs should be our one value over here. Now ultimately, if you just do apply the impulse response in this transfer function over here, we are having the Cs divided by 1, that is actually A divided by our S plus sigma. Now once again we are having that the Cs is equal to this one. Now at the last stage, if you just do apply the inverse Laplace on this given equation, we are actually having our considered equation. If you just do apply the inverse Laplace, if you just do apply inverse Laplace transform on this Cs is equal to A divided by S plus sigma over here, and I am just going to repeat over here once again. We have applied the impulse response as our input over here. That is why I have considered that Rs is equal to 1 over here, and at this equation, if you just do apply the inverse Laplace transform on this given equation, we should go to the CT or the time domain output equation over here, which is CT or output response over here, which actually give us A e to the power minus of sigma t over here. That is been considered over here, A e to the power minus of sigma t over here. And first we have formed the transfer function just by looking at this location of our S-plane over there, and according to our S-plane consideration over here. Now what is the considered point? I'm just going to consider over here what is the crucial steps over here. At first, we have located the pole of our S-plane over here, and according to that S-plane, or according to that location of our poles on that S-plane, we have plotted that accordingly over here. And in our next stage, just by looking at this S-plane over here, we have formed the transfer function, which is Cs divided by Rs. That is this one, and A is some form of constant over here that has been associated, or that has been placed at the numerator, but the location of our pole is much more important over here, and I have put that over here, which is S plus delta. Now in our next stage, if you just do apply the impulse input response on this transfer function equation, we should put Rs is equal to 1, and that actually implies that Cas divided by 1, which is equal to A divided by S plus delta. Now in our next stage, if you just do apply the inverse Laplace on this given equation, we are having Ct, that actually give us A e to the power minus of our sigma t over here, and this is our final equation that we are having as our mathematical expression over here. But the mathematical expression is not so important over here, but the most important part in this class will be quite naturally how do you define that much needed output Ct versus time over here, that is been reflected over here once again. Now if you just do plot this mathematical expression of Ct is equal to A e to the power minus of sigma t over here, if we just do plot that, we are having this is our considered point, or this is our waveform over here. Now how do you analyze that, whether the system is stable or unstable? If you just do increase the time tends to infinity, it actually do give us that it has started from A, because if you just put e to the power 0 over here, that actually give us the A. That is why the waveform has started from our A point over there, and if you just do increase this minus of sigma, increase this time factor over there, which actually give us e to the power minus of 2 sigma minus 3 sigma and so on, the curve will be going towards our 0 over here. Quite naturally, I can say that the system is stable. Why? Because if you just do increase the time, which is time t tends to infinity, the waveform, the output response will go to the 0 over there. That has got the finite value over here, and there is some possibility to have the finite value in our future consideration over here. That is why I can say that in this case, because of this location of our pole, which is S is equal to minus sigma, the waveform accordingly, or according to our time domain analysis, or according to our CT waveform over here, we can say that the system is stable. Why? Because if you just do increase the time as our time t tends to infinity, the output waveform will go to the 0 over here. That actually give us the exact characteristic of a stable system over here. In our next class, we just do want to configure or do analyze this one over there. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section. For better understanding, do like, do share our videos, and keep following our channel. Just wait for my next part. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.